आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
After the successful Chandrayaan-3 mission and the unlocking of space sector by PM Narendra Modi, sky is not the limit for India's space journey, says Dr. Jatendra Singh, Union Minister of State, Independent Charge, Science and Technology, MOS, PMO, Personnel, Public Grievances, Pensions, Atomic Energy and Space. Dr. Jatendra Singh today said, after a successful Chandrayaan-3 mission and the unlocking of space sector by Prime Minister Shri Narendra Modi, sky is not the limit for India's space journey. Dr. Jatendra Singh was delivering the inaugural keynote address at Campus Dialogue on Chandrayaan-3 under the theme Viksit Bharat at 2047 at Central University of Jammu today. While interacting with the academia and students, Dr. Jatendra Singh said India's quantum leap in space research with India's space economy standing at $8 billion has been only possible due to the courageous decision taken by PM Narendra Modi to unlock the space sector from the shackles of the past. India's space economy projected to grow beyond $40 billion by 2040, and as per ADL author D. Little report, India's space economy has the potential to go beyond $100 billion by 2040, which is going to be gigantic jump, Dr. Jatendra Singh added. On the successful conduct of G20 summit and Chandrayaan-3 mission, Dr. Jatendra Singh said, India today is at par with countries such as United States, which commenced their space journey decades before us, stating that India has made a quantum jump in its space journey in last 9 years. The minister said, Prime Minister Narendra Modi led government has created a supportive ecosystem. He added that the space sector has been opened for public-private participation with a swift increase in number of space startups.
Now, our next segment is Analyst in STEM.
Today we are with Dr. Piyali Chatterjee, Associate Professor, Indian Institute of Astrophysics.
To begin with, can you brief us what your area of research is and what drew you to the particular field?
Yeah, thank you, Arya, for the question. Actually, the sun that you see every day, the visible surface of the sun, the disk of the sun, that's not the end of it. Beyond that, we have the atmosphere of the sun, which is actually a very dynamic place, and that's where a lot of action takes place. And it's a place most of the solar astronomers want to study. So, as you know, the sun and its atmosphere is made of plasma or gases that are ionized into positive ions and electrons. And actually, the density of this solar atmosphere is much less than the density of air here on Earth, like 1 billion times less dense than the Earth's atmosphere. But surprisingly, it is also very hot. So I work on these plasma processes, understanding these plasma processes that are going on in the atmosphere of the sun. And we basically employ certain techniques like solving mathematical equations that are known as partial differential equations. And we try to find how matter, waves and energy, they propagate through this region. Then we try to match these results with observations from different space-based and ground-based solar observatories. So ultimately, the goal is that such studies should answer the question on the origin of the solar wind. So as you know that there is this constant stream of wind that flows out of the solar surface and pervades the entire heliosphere, and how that wind originates and energized and gets its mass from, there are a lot of unanswered questions in that area. So that is our grand goal essentially. So we try to do our bit to understand this grand challenge problem of the origin of solar wind.
So how would you say your research is useful for the common man or India as a whole in the field of science?
Yeah, so sun of course is our nearest star, and being nearest to us, it is we can resolve it very well when we look at it through telescopes. And therefore it is a very handy laboratory to study plasma physics. Because the plasma in the inside the sun and in the atmosphere is in extreme conditions which we may not be able to produce in an earth-based laboratory. So in order to study those complex plasma processes, we should focus on understanding our sun. And here, we can also test theories of nuclear physics, light, and how light and matter interacts, magnetic fields, electromagnetic theory, and theories of relativity, and a lot of other things. So, of course, that's something we should not forget, that, we can test a lot of our theories against the observations that we take of our nearest star. So that's how I think that is something that is relevant for everyone.
Could you brief us on your past, present, and future areas of study?
Okay, so in the past, my research has focused on how magnetic fields are generated inside the sun. So as you know, a lot of people would know that there are these features known as sunspots on the surface of the sun, which appear and disappear with a time period of 11 years. So the number of spots increases and then decreases. It's like a sine wave that is in time. So, it has been found long ago using the Zeeman effect that these sunspots are in fact magnetized, have very strong magnetic fields. So what is the source of those magnetic fields, and why does the sun have an 11-year sunspot cycle like this, has been the focus of my research in the past. And we then applied this knowledge to predicting the strength of the solar cycle. So what it means is we try to predict the maximum number of sunspots that was possible in this solar cycle, because as you know, the number of sunspots, the more number of sunspots there will be more solar flares and coronal mass ejections, which are like solar storms, which sort of affect the Earth directly. Because of our various anthropological activities, like we have a lot of space assets nowadays, a lot of satellites in space, and not India, because India is a tropical country, but the countries that are in the northern or the southern, extreme mid latitudes, they experience this phenomenon of auroras, for example, which is actually a result of this magnetic cycle. Basically those flares and CMEs, they interacting with the Earth's magnetic field. So it's a result of the sun's magnetic field interacting with the Earth's magnetic field. So the sun and the Earth, they are not just attached to each other by gravity, but also through magnetic fields. So that's an interesting thing to put down here. And later I worked on an area known as helioseismology. So as you know, seismology is an area where you study earthquakes to understand what is the internal structure of the earth, core, mantle, crust, and things like that. So similarly, we use this, sound waves, which basically propagate, are trapped inside the sun. So it's like a box in which there are these standing sound waves, and these standing sound waves make the sun ring like a bell, right? So then you can use the nature of these waves to predict what the sun is actually made of. So this area is known as helioseismology. It's quite an interesting area of research, very mathematical. But you get to know, it's amazing that you can't see inside the sun because the visible surface is opaque. But using this, you can predict what are the flows, what is the sound speed, what is the temperature, and these things inside the sun. So presently, my research also focuses on the genesis of solar storms. The solar storms, for example, flares and coronal mass ejections, and how are they born. So this is especially important from the point of view of India's first solar mission, Aditya L1, that is going to be launched in 3 days from now, on 2nd September, by ISRO from the Satish Dhawan Center in Sriharikota. So one of the primary payloads on this Aditya 1 spacecraft was actually designed and built at IIA Bangalore. The payload is called VELC, or Visible Emission Line Coronagraph. So the idea is that what are coronagraphs? So as you know, the solar eclipse is when the moon covers the disk of the sun, and that's when the bright disk of the sun disappears and you can see the corona, which is like a crown around the sun, which is also very beautiful. And that's where all these flares and CMEs are thought to be. So basically this VLC payload carries a coronagraph, which is, now these solar eclipses don't happen all the time, right? They have these seasons. So the coronagraph has a sort of an instrument where you can cover the disk of the sun all the time, and then you can see the dynamics of the corona. I mean, as I already mentioned before, that these solar storms are what drives the space weather. For example, our Earth's weather is driven by cyclones and monsoon and wind patterns and things like that. So the space weather, which is basically the weather around our Earth, the geospace, is governed by these kind of storms. And therefore it is important to understand what is the origin of these storms and how frequently they can occur, and ultimately predict even before the storm occurs that there is such a storm going to happen. So now these storms can cause a lot of damage. For example, the satellites, as you know, have these solar panels, right? So if we are not careful, or if the people who are operating the satellite are not careful, do not shut down those panels on time, they can get damaged, and you can lose satellites because of that. And you may have read in the news that this what is it called? The Starlink satellites, which Elon Musk's Starlink satellites, where all tens of satellites, I think 20 or something of the satellites were lost because of such a solar flare, which basically changed the drag of these satellites, and they just spiraled and fell to the earth instead of being in a stable orbit. Those are basically the effects, and we therefore need to study the cause. So going back to my work again, which is little off from these eruptive, very energetic phenomena. So recently we were investigating parallels between numerous jets of plasma known as solar spicules that are seen on the solar chromosphere. So the solar chromosphere is a thin layer just above the visible layer of the sun, which is known as the photosphere. So these spicules are seen in the chromosphere, and they appear like a grassland, like a savanna around the sun. And what these jets do is they go up and they fall back down under gravity. And because there are so many of these jets, people believe that the solar astronomers believe that it may be playing a role in driving the solar wind, which is this all-pervading constant wind around the sun. So then we compare these spicules to a popular science experiment that people can watch on YouTube that involves having paint put on a speaker, and you turn on the music and the paint starts dancing, and then you get these jets that form. So even though it seems a fun experiment to watch, and I would encourage our listeners to go and watch some of those videos on YouTube, but it has a lot of interesting physics hidden in it, something that you can do in your lab, in your high school lab actually, to understand what forms solar spicules on the surface of the sun. So technically this phenomena in the fluid dynamics community is known as Faraday excitation. And in nature, you can also find it in the mating calls of the male crocodiles. So what the crocodiles do is they sink their back under the lake and they start singing at a frequency of 20 hertz or so. So it's like a really bass singing. And as they sing, the water forms these jets, which actually looks very much like solar spicules. But we found out it's not just visual similarity, but there is a lot of mathematical and phenomenological similarities as well. And ultimately, we could put down 4 basic criteria that are sufficient for formation of such jets, be it in astrophysics or in the laboratory. And we think it's quite an exciting thing. I mean, we enjoyed doing this research quite a bit. So there are other people who contributed to these research whose names I would like to mention. So one is Shohil De, who is my PhD student, and that's part of his thesis work that he has submitted now. And also my collaborator Murthy from Azim Premji University, who is an expert on these fluid experiments, and we sort of collaborated and created this interdisciplinary work, which we are really very excited about.
Where would you say India is ranked at present in terms of research in this particular field?
Yeah, so actually in solar astronomy specifically, and also in other branches of astrophysics, I think in terms of theoretical and computer modeling, we are just starting. Theoretical work, a lot of it has been done, but when it comes to computer modeling, it is quite challenging because of resources. There are a lot of people who work on observational data analysis and analytical models and their interpretations, but we do not have yet a big community of people who do computational modeling. Because our resources are less, unlike in the Western world, so it will take a lot for us to compete at the same level, because they are able to do really large-scale, state-of-the-art simulations, but we just don't have the capability. But certainly we can try to do things differently and more efficiently, and I think some of us, including a lot of my other colleagues, are also trying to do this. And now we also have these observational mega projects like the Aditya L1, and we also have an upcoming 2-meter class solar telescope called the National Large Solar Telescope, or NLST, that is in the planning to be set up on the shores of the Pangong Lake in Ladakh. And however, unfortunately, these mega projects do not have any computing support. So if these projects also keep aside some money for computing support, then it is possible to produce very strong and impactful research papers from India by combining observations and numerical simulations. So, we can indigenously do a lot of things without collaborating or without depending for a lot of things on our Western counterparts.
Would you brief us on any contemporaries or competitions with regard to your research?
Oh yes, there are several big groups, both in US and in the Europe, and they are doing very good work, very detailed and really state of the art. And you see them, you actually think, how do you compete with these people? But then one of the things that I see in those groups is they get confined in their own small ideas, and they're not able to come out with or give fresh insights or fresh look into the problem. So whatever they have thought of, they keep spiraling in the same vortex. So I think from a developing country, we could do that thinking more, because we can think, and since we don't have resources, we sometimes think better. And also I would like to say that being a woman and from a developing country, women scientists from a developing country, there are challenges. For example, even though you write a good paper, there is a lot of visibility and you get speaking invitations. So people tell you, yeah, I have read your work, it's very nice. But actually when it comes to citing the research, that is lacking. Say they don't want to cite research from developing countries. And probably also there is some kind of gender bias, because if there is a woman leading a project, they do have some reservations too. But I hope with time, all our work from India, not just from my group, but also from my colleagues who are all my friends across India, they will get more acceptance in terms of citations, and our students being able to go out and speak for themselves more. So that's something that is a challenge in India, but I look forward to the change.
How is the Indian industry affiliated with such projects?
So for example, like I was talking about computational modeling. So right now we have as you know, the government of India started this national supercomputing mission, under which it set up a lot of supercomputing clusters on nodes in different institutes, like mainly IITs and IISc and even JNCSR. So we got to use such facilities, of course, for a fee. However, that is we would want that there is some reserved time for astrophysics problems, which there is not right now. So that is something we would urge the NSM project to look into. And therefore, many of our calculations have so far been done on indigenous supercomputers, and we are very proud of it that we don't have to go begging people for a time, but a lot more support is required so that we can afford this kind of computing. And also about other projects that are carried out at IIA. For example, ISRO funds these space-based projects. For example, the VLC payload on Aditya L1, the construction was funded by ISRO, and then it was effected by the scientists and engineers at IIA. So we have these kind of collaborations. The private funding, well, I am not aware so much of private funding in IIA. From companies, but I'm sure there are a lot of private players now trying to enter the space projects, and I think ISRO itself collaborates with a lot of private companies which manufacture small parts for their rockets and payloads, etc. But I'm not an expert on how that collaboration goes on.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts